We're live. Woo! And this is Math 60. This is Intermediate Algebra. This is Godzilla. This is the bear. And this is graphing circles. And this is the hard one. So let's dig in and see how to get through this problem. So the first thing is that's going to be really important is recognizing that this is actually a circle. So how do we know that there is a circle involved here rather than say a parabola? And the answer is, do you see both x and y are squared? That tells us we've got a circle. Now, to be honest, in your next class, you might learn that you could also have a couple other things like an ellipse or a hyperbola. Some other interesting things could be happening. So, but for right now, both x and y are squared. That means it's a circle. And just if you're curious about peeking ahead, x squared and y squared both have the same coefficient, which tells you it is a circle. So that's how you would know. If it were x squared plus 2y squared, then we got something else going on. And then we'll talk about what that in your next class. Okay, so if when you have one thing squared, you have to complete the square once, how many times do you have to complete the square for a circle? Yay! Yes, you're right. So we're going to complete the square twice. This is going to be a whole completing the square palooza. The good news is we're back to working on both sides again. So let me show you what I mean by that. So I've got x squared, and then I'm going to take the minus 4x and give myself some space. I'm going to take the y squared and the plus 2y, and then I'm going to get the minus 11 equals 0. Okay, first thing I'm going to do is I'm going to totally get the minus 11 over to the other side. So I've got x squared minus 4x, y squared plus 2y, and 11 on the other side. Just being, this is getting ready to be our radius. I hope this is not our final radius, because this would be, we have to take the square root, and the principal square root, that is radical 11, which would not be fun. I don't want to count radical 11. So let's, fingers crossed I've picked a good one. We will see. So we're going to just complete the square for the x's, and then we're just going to complete the squares for the y's, right? They're going to be separate. For the x's, I take the minus 4 and I take half of it, and then I square that. Okay. For the y's, I take 1/2 of the 2, and then I'm going to square that. And then, if you're ready, I get x squared plus 4x, and then I'm going, oop, haha, I remembered my colors. I'm going to do a plus 4 here. And then over here on the other side, I'm going to add 4. Now you could compensate on the same side if you wanted to, but ultimately all the constants in a circle constants always go on the right-hand side. So I'm just going to put it over on the right-hand side. So when you compensate on two sides of the equation, you do the same thing. If we were doing it on the same side of the equation, it'd be plus 4 and then minus 4. You do it and then you undo it. If you do it to both sides, it's you do it and you do it. Okay. I'm going to need another color. I've got my y squared plus 2y, and then I'm going to add in a 1. We'll give a blue square here, and we'll put it over here. So I'm going to add in a 1 here and a 1 there. This is, I copied something down wrong, and I'm having a terrible time because the bunny got all excited about the math. Do you see the error? Take a good look. I have a little tiny mistake. Well, it's a great big mistake, actually. Make the world a little harder to do. Look at that. I did. You guys were probably yelling at the screen. You're like, no, Miss Saunders, it's minus 4x. Okay. So thank you so much for yelling at the screen. I'm sorry I didn't see it. That should be a minus. And I'm just feeding my tiny little addiction to correction tape. I just love it. It's like magic. I love it. I wish it would work in the rest of my life. Like I say something stupid and I could just go whoop and everyone would be like, "Oh, we didn't hear you." Or like I make a bad choice or I buy something I don't really want and then I could just go whoop and it's undone. Wouldn't that be amazing? Okay, so here I'm going to have x minus 2, the quantity squared. Remember, I can cheat by looking at this first number I get after I did 1/2. That number is going to be this number right there. Okay, plus y plus 1, the quantity squared, equals, and over here I've got 11 plus 4 is 15 plus 1 is 16. Oh my gosh, I'm so excited. Why am I so excited? That's a perfect square. Our life is saved. I mean, I don't know if that's true, but certainly right now my life will be a little bit easier. So I'm going to write it in standard form. I've got the x's squared, the y's squared, and the 4 is squared. So my center is at, remember, take the opposite. It's 2 comma -1. And my radius is 4. And this is enough to graph. Now, will we know what the intercepts are? No, we won't. We won't at all. And life is going to be hard, but we'll get through it. I've got another piece of paper. We're only at 6 minutes. We can totally do this. We can totally do this. Okay. So for my graph, let's see. I'm going to be at 2, -1. My radius is 4. I'm just going to put my axes in the middle. And again, I am absolutely using a ruler. You can see that I am using a ruler. And I am perfectly straight. Not. Okay, so 2, -1. So my center is right there. I make a little note, but I don't make it too dark because it's not part of the graph. And then I count up 1, 2, 3, 4. And this point is at x equals 2, y equals 3. So this is a 2, 3. 1, 2, 3, 4. This point is at -2, -1. 1, 2, 3, 4. This is at 2, 1, 2, 3, 4, 5. And 1, 2, 3, 4. Oops, I almost didn't have room for this. This one is at 3, 4, 5, 6, 6. 6, 6, -1. Okay. You don't have to write the numbers in. Sometimes I just like to. Okay, so then with a compass or freehand, do your best. Oh, this is not my best. This is possibly my worst circle ever, but it's a little squished. It's been a day. This is my circle after a long day. And the problem is we do have 1, 2, 3, 4. We've got 4 intercepts. But I've got a stack of paper. So let's pull out. So this is number 3, continued. And let's use x minus 2, the quantity squared, plus y plus 1, the quantity squared, equals 16. And let's find the intercepts. Now, I'm going to guess of the 2 methods that we used on the previous one, you're probably going to prefer, I don't know, I would prefer the second one. So I'm going to do the second one. You guys can do this however you like. Basically, you plug x equals 0 in. So you get 0 minus 2 squared plus y plus 1 squared equals 16. So this is going to be 4 plus y plus 1 squared equals 16. Subtract 4, subtract 4. Y plus 1, the quantity squared, equals 12. Okay. Square root y plus 1 squared equals plus or minus square root 12. Now I'll point out that 12 is equal to 4 times 3. So we're going to end up, this 4 is going to break out and going to be a 2 radical 3 because that's 2 times 2. Okay, so this is y plus 1 equals plus or minus 2 radical 3. And then Subtract 1, subtract 1. Yeah, I like this much better than the other way I was doing it. Oh my gosh, so much better. So I've got -1 plus 2 radical 3 and -1 minus 2 radical 3. And these are the y values. So they correspond. I'm sleepy, so I suddenly have a vocal fry. So they correspond to 0, comma, -1 plus 2 radical 3, or 0, -1 minus 2 radical 3. Woohoo. Okay, so those are the, what intercepts are those? If x equals 0, those are the y-intercepts. So back on our graph, these are these two. And let's see, this one's the plus one, so it's the bigger one. So right here, I've got the point 0, comma, -1 plus 2 radical 3. And down here, I've got the point 0, -1 minus 2 radical 3. There we go. Oops, you couldn't see the top one, sorry. Woohoo. Okay, we got 2 more to find, those 2. We can do it. You guys are awesome. We're getting there. Okay, number 3. Wah! Oh, this paper does not want to be part of this. Okay. Oh no. Well, that paper doesn't have a choice because I don't have any other papers. So we've gone through a ream of paper. Oh my gosh. Continued. Sorry about this morning. X minus 2, the quantity squared, plus y plus 1 squared equals 16. So how tired are we? Well, we just went through a ream of paper tired. Wow. So this time I'm going to let y equal 0. So I've got x minus 2, the quantity squared, plus 0 plus 1 squared equals 16. So far, so good. X minus 2, the quantity squared, plus 1 equals 16, minus 1, minus 1. X minus 2, the quantity squared equals 15. I'm very excited about this. And it's kind of a weird way to get excited because 15 as a radical does not reduce at all. It doesn't simplify. So we're just we don't have to worry about any bears or anything. We're just like, oh, sweet release here. Radical 15 is just radical 15. Sometimes a radical is just a radical. Plus 2, plus 2. You guys are going to be so good at math when we're done with this. If you've been following along doing this, oh my gosh, you're going to own the world. So my x is 2 plus radical 15 or 2 minus radical 15. And again, if you don't know what this equals, it's not a bad idea just to do what we call, well, honestly, it's called a sanity check, which I'm not sure is all that appropriate. I'm sure you guys can come up with a better phrase for it. That was the one I was taught. 2 plus radical 15. Just a quick check to make sure we're not completely off. So this is about 5.9. And 2 minus radical 15 is about -1.9. Okay, so let's look at the graph and let's see if these points make sense. So 5.9 is this one, and this is 6. See how I'm right close to 6? So this point, 2 plus radical 15, comma 0 makes sense. Now let's look at this one. See how I'm just to the right of -2, and I should be at -1.9? So that's great. We did it. I'm going to put this one over here. 2 minus radical 15, comma 0. And I realized that with the first one, we never did that double check. So let's do that double check. What it means with the first one, with the y-intercepts, let's just double check what the values are to make sure that they make sense on our graph. I've got -1 plus 2 times radical 3, which equals, this is about 2.4, 2.5. I'm going to say about 2.5. On this one, -1 minus 2 times radical 3. And this one is about -4, 4.5. So let's take a look at our graph. 2.5. Yeah, I could believe that. I didn't draw a great circle. There's 2, there's 3, so we're in between 2 and 3, so I could believe that. And then here, 1, 2, 3, here's -4. Are we at -4.5? Yeah, we're really pretty close. So we did it. We did it, guys. We did it. We've got our graph. Now, let's label it proudly. You could label it a bunch of stuff. X minus 2 squared plus y plus 1 squared equals 16. Big old label. We're going to call in our friends. Hey, friends, guess what? We just finished graphing all the hard circles. Yay, it's time for dance party, math dance party. Ah! Okay, so you guys did it. You're brilliant. We've got a graph. You're smart. Don't let anyone tell you any different. You're amazing and smart and incredible. And I miss you. And that's it. Take care. Math on. Woohoo.